Hey everyone, in this video we are going to continue solving quadratic equations, this time by completing the square. And so this method is one of the longer ones, but I'm going to walk you through it. And so we have these four main steps. Number one, make sure that the leading coefficient equals 1. Number two, add the missing term, and we'll find that. Number three, factor the perfect square trinomial. And then number four, solve using the square root property. So in the previous video, we walked through solving using the square root property. And so we're going to use that here as well, eventually in each of these questions. So starting with number one here. The leading coefficient is already 1, so we're good to go there. We are going to find the missing term and add it. And so here's how the missing term goes. You basically just look for the same format every time. You take half of this term in the middle, the coefficient, and then square it. So we are going to take half of negative 12, and you can write it in steps, half of negative 12, and square it. Every single time this is the process. And so that's negative 6 squared. And so what we're going to add, the missing piece, is 36. And I'll tell you in just a moment why I call it a missing piece. So I have an equation here. So what I'm going to do is I'm going to take this missing piece, and I'm going to add it to, actually let's change the color. I'm going to add it to the left side right after the x terms, okay? And then I had a minus 3 right here still. This equals 0. And then it did equal 0 before, but because I have an equation, whatever I add to one side, I have to also add to the other side. Okay, so we are adding this missing piece to the left side because when you do this, you have what's called a perfect square trinomial. And so let me just highlight that. This part here, these first three terms, is a trinomial that is a perfect square. It's something squared. It's very nice when you factor it. And this one happens to be x minus 6 quantity squared. We still have a minus 3 in the very back, but what I'm going to also do is I'm going to just move that 3 over. So I'm going to add 3 to both sides. And so we have that this equation equals 39. Now, there is a nice shortcut here. Let me just mention it really quick. Whenever you're looking to factor your perfect square trinomial, if you look at what you did on your side work, right before you square this term to find the missing piece, that number actually always ends up in your factor. So it's a very nice shortcut for factoring when you use this method. And so now we're already onto the step where we're going to use the square root property. So when you take the square root, and let me just rewrite this to give us some more space, you always just have to put a plus and minus on one of the sides of your equal sign when you take the square root. And I always put it on the side with the number. So square root, both sides, and then plus and minus on one of them. Because when you square something, if it was negative to begin with, when you square it, it turns positive. So we put the plus and minus when we go backwards. So the left side, let's just move over here, is just x minus 6 because we undid the square with the square root over here. And then the right side of the equal sign is plus and minus square root 39. Now, if we could simplify square root 39, if it had a perfect square in it, then we would simplify that. But 39 is 3 times 13, and neither one of those are perfect squares. So the only real thing I can do here is one more step and get x by itself. And so I end up with x equals 6 plus and minus square root 39. And that's two separate answers, but I'm just listing them as one. But technically it's 6 plus square root 39 and then 6 minus square root 39. So on this next one, we do have to do this first step because our leading coefficient right here, 3, is not a 1. And so we can do this two ways. We can factor out a 3, or because this isn't an equation, we can actually divide both sides of the equal sign by 3. And in this case, I'm going to go ahead and do that. It will just give us a little bit less work to write because we don't have to keep track of that 3 if we were to factor it out. So the first term just becomes a squared. Now the second term, 3 doesn't go into 2, so we have to write that as 2/3 a. And then same thing in the last term, we have to write that as a fraction, minus 1/3. Okay, so now we're going to find the missing piece. It's going to be half of this middle coefficient squared. So I'm going to take 2/3, but I want half of it. So let me write it like this for you. Half of 2/3 squared. That's the missing piece. So if we simplify, this is 1/3 squared, which is 1/9. So that's our missing piece that we're going to add to both sides of our equal sign. So we have a squared plus 2/3 a, and then let's add our missing piece right there, plus 1/9. Now we have this minus 1/3. I'm just going to go ahead and move this over right now. So that's going to be a plus 1/3 on both sides. And then here's why. So I have equals 1/3. But whatever I add to one side of my equal sign, I have to add to the other. So I'm going to put that plus 1/9 over there with that 1/3 that we just moved. And so now everything that's on the left side of the equal sign is our perfect square trinomial, all of this. And so it factors really nicely as some quantity times itself or squared. And now this one might be a little harder to factor. You can think about it, okay, how would I factor this? What multiplies to 1/9 but adds to 2/3? But if you remember the shortcut I just mentioned, if you look back at your side work over here, we can factor really quickly if right before we squared to get our missing piece, we put that number in our factor. So we can just say that this is a plus 1/3 quantity squared. And if you're ever not sure, you can FOIL this out. So if you want to check, just FOIL this out and it'll take you back to right here where we just came from. Now let's make the right side look a little better. So common denominator real quick. We have to add fractions. So let's say 3/3 right there. And so we end up with 3 plus 1/9. So that's 4/9. Now is the time to take the square root. So square root property, take the square root of the left side, square root of the right side, but put a plus and minus. So on the left side, we're just undoing the square, and we have a plus 1/3. Let's just put an arrow here. And on the right side, we have plus and minus square root 4/9, but we actually know the square root of that. Square root of 4 is 2, square root of 9 is 3. So plus and minus 2/3. We're going to move over this 1/3, okay, by subtracting because we want to get a by itself. And so we have a equals, I'm going to put the minus 1/3 in the front and then plus and minus 2/3, okay? So I don't want to box this in because I actually can combine these. So let's actually break it into two cases here because of the plus and minus sign. And so we have a equals negative 1/3 plus 2/3, and then a equals negative 1/3 minus 2/3. And so my final answers here, I would just say that a equals 1/3, and then down here, a equals negative 3/3, which is just negative 1. Okay, and that is our answer to number 2. And again, you can always check if you want. Plug both of these answers back into the original and you should get 0. So let's try number 3. So we do have to divide out our leading coefficient of 2 here. So I'm going to divide both sides of this equation by 2. And so what we end up with is x squared minus 6x plus 3/2 equals 0. And then let's find our missing piece. So we're going to take half of negative 6 and square it. So that's going to be negative 3 squared. So our missing piece is 9. So let's add 9 to both sides of this equation. So we have x squared minus 6x and then plus our missing piece, 9. Now at the same time, I'm going to go ahead and move over this minus 2/3 to the other side of my equal sign and then add my missing piece to the other side as well. So we have that this equals negative 3/2. I think I said 2/3, but negative 3/2, and then plus 9. Okay, so the left side of our equal sign is our perfect square trinomial. So this factors really nicely. This factors as x minus 3 quantity squared. And then the right side, let's go ahead and figure out what that equals. We do need a common denominator. So if you multiply 9 by 2/2, we end up with negative 3 plus 18 over 2, 15 over 2. Okay, so now we're ready to take the square root of both sides. Let's just go ahead and move this over. So x minus 3 squared equals 15 halves. And then we'll take the square root of both sides, remembering to put our plus and minus. Okay, and so on the right or the left side, we just have x minus 3. The right side, we do not know the square root of 15 or 2. Without a calculator, it's not a perfect square, so we're going to leave that. Now we could rationalize that, but for right now I'm just going to go ahead and move over this 3 to get x by itself. And so we have x equals 3 plus and minus square root 15 over 2. And we cannot combine these terms, or you can rationalize it just so you're aware. You can write this square root 15 over square root 2, and then just a little step here, multiply top and bottom by square root 2. And so this becomes square root 30 over 2 because you squared this here. So let's try this one more time. Now this equation, number 4 here, we've seen this on the previous videos. We've solved this by graphing, by factoring, by using the square root property. Now this time, we don't really have to do anything to complete the square. This is the same work as the last one. We are good to go as long as we move over the minus 1. Because, oh sorry, that's a minus 3 there. Because we already have a quantity squared. So we don't even have to do the completing the square step. And so if you solve this using your square root property, we've seen this answer a few times now. This is x equals 2 and x equals 4. So no need to do any work on that one other than square root property. Okay, so that's it for this one. And in our last video on this topic, we're going to solve using the quadratic formula. So see you in the next one.